Hello everybody. This is going to be a short video, I hope, because there's really only one concept you need that's kind of new to this chapter. Most of it is review, and I want to just give you some examples first and then just give a definition of point of inflection. But there's a question on the worksheet where there's this crazy curve, and then I'll try to make a better crazy curve. And you're supposed to say whether the derivative is positive, negative, or zero, and whether the function is positive, negative, or zero, and the concavity, or in other words, the second derivative is positive, negative, or zero. Okay, so let's try to talk about that. Okay, so first of all, you should know that you're going to be given later in the class some kind of algebraic expression, and you're going to take the derivative, set it equal to zero, take two derivatives, set it equal to zero, if you can set the function equal to zero, and then you're going to break everything up into positive and negative and zero for each of those, and then try to graph it. So in this case, let's see, there's a zero here and here on the function. So for example, wherever this is, I'm just going to label this A, x is A, x is B. So for f, from negative infinity to A, and from B to infinity, f is positive. And at A and B, f is 0, and then from A to B, f is negative. So I've just analyzed f. This should be really easy because it's just a little visual thing. Now, if we want to look at the derivative of f, well, the derivative of f has to be 0 wherever the original function has a max or min. Okay, so let's see, I can sketch this derivative. It's probably not a bad idea. So when we go from the min to the max, the function is increasing, so that's positive, so we get a little hump like that, and then it just kind of alternates. You can sort of extend this a little bit. Alright, so I'm going to call this point here, I guess the drawing isn't perfect. I should have come down more like this. But I'm going to call this point C, D, E, and F. Alright, so F prime, so the blue one is F prime. The first one I drew is F, the second one is F prime. F prime is negative from minus infinity to C, and from D to E, and then let's say F to infinity. It's negative, and then it's going to be at C, D, E, and F, it's going to be 0, and then it's going to be positive between C and D, and E and F. I guess I was using union notation. And E and F, it's positive. Okay? And so then we want to talk about what the other derivative is doing. And I'm just going to erase F prime for a second. You normally wouldn't, but this is looking kind of sloppy. So I'm going to give myself more space, hopefully, and try to talk about the second derivative. You usually, like I said, you usually talk about the second derivative by looking at the first derivative. But I'm going to try to just discuss what's happening directly by looking at f. Remember I said concavity tells you if it's concave up, it's positive, concave down, it's negative, and we're talking about the second derivative here. So I'm going to split it into regions where it's spilling water and holding water, and I'm going to do that directly off the first graph. So right here, this whole thing appears to be concave up, so it's positive, so F double prime is positive, and I'm going to call this G. And then right around here it splits again, let's say right around here. So I'm imagining, like, if this is an umbrella, this is where the umbrella covers me. It's the umbrella that's covering me. I don't want an umbrella that concaves the wrong direction, because this is going to just collect water on the top of the umbrella, or it's going to turn into a cup, right? So from H is a cup up till maybe, actually, maybe right around here. So maybe that's I. And then everything else is concave down. So this part is F double prime negative. This piece is F double prime positive, because, you know, it's a cup. You're collecting water. And then F double prime negative, you're spilling. Okay, so I would say F double prime from minus infinity to G, and then from H to I is positive, and on those points G, H, I is 0, and F double prime is going to be negative from G to H, and from I to infinity it's negative. Okay, so spills water, holds water. All right, so the point is, what is this point at which we switch from holding water to spilling water, or vice versa? This thing is called a point of inflection. We call it a PI. All right, and it chops it up into pieces that look like this. Concave up and concave down pieces get connected at their points of inflection. So if I connect these two pieces, then right there I joined it at a point of inflection. So that's similar to what happens in the first derivative. But the first derivative, you have points of increase and decrease. And when you join points of increase and decrease, so this point gets joined, then you get what's called a maximum, a local maximum. And if you join a decrease with an increase like that, you get a minimum. Okay? So when you join increases and decreases, you get maxes and mins. Yeah, that's lovely writing. And this is a min. And if I join a piece that's concave, this whole thing is now concave down and this whole piece is concave up. If I join those pieces, I get a point of inflection. And that's why I like to use the arcs of a circle. I like to draw sketches for class using these circle arcs, because then I get all the kinds of connectivity I want. And the way this is drawn, obviously, it doesn't really make sense because these pieces can't connect together. Those guys can connect to these guys, like that, like so. All right. That's all the new concepts you need for worksheet 11. Just a quick review. F is position. And if you want to talk about the sign of it, you just literally look, is it above or below the axis? It's positive, or it's negative, or it's 0. F prime is also velocity. And you will look if it's increasing or decreasing, if the function is increasing or decreasing. If F is increasing, then F prime is positive. If F is decreasing, F prime is negative. And F double prime, otherwise known as acceleration, if F spills water, then F double prime is negative. If F holds water, yeah. F holds water, F double prime is positive. And hopefully those visuals will help. And I will see you in class soon.